Good morning, students. How are you all? Our topic today is conic sections. We are going to start with definition of some terms. Definition 1. A conic section is a locus of a point which moves so that the distance from a fixed point called focus to the distance from a fixed line called directrix is in a constant ratio. Definition 2. The ratio of the distance from a fixed point called focus to the distance from a fixed line called directrix is called eccentricity. And eccentricity is denoted by small letter e. In a simpler form, we can define eccentricity as the ratio of the focus to the directrix. Ratio of focus to directrix is called eccentricity. Note, a conic section also has a vertex and latus rectum. Now, what is the meaning of a vertex? Vertex is the coordinates of a point where the conic section cuts the x-axis and y-axis, that is, where x equals 0 and then y equals 0. If you want to write this in coordinate form, it gives us 0, 0. Definition 4. Latus rectum. Latus rectum is a vertical line through the focus to the conic section. A vertical line through the focus to the conic section. Example of conic sections are parabola, ellipse, and hyperbola. Note, for a parabola, its eccentricity equals 1. For an ellipse, its own eccentricity is less than 1, while the eccentricity for hyperbola is greater than 1. So we are going to take examples of conic section one after the other, starting with parabola. What is a parabola? A parabola is a locus of points equidistant from a fixed point called focus and from a fixed line, directrix. That is the definition of a parabola. Now, let's see the diagram of a parabola. This is how it looks like. This diagram of parabola showing the vertex represented with letter V, focus represented with letter F, and then line RQ is the latus rectum. Equation of a parabola. 1a. If the vertex is 0, 0, that is at the origin, and the focus is a, 0, then the equation of a parabola is y square equals to 4ax. Y square equals to 4ax. Note, if the focus is a, 0, then the directrix is negative a, 0, or you simply put x equals to minus a. Mind you that a is from the coordinate of the focus. 1b. The equation of the parabola can also be x squared equals to 4ay, provided the vertex is 0, 0, that is at the origin, and the focus is 0, a, That is the major difference between 1A and 1B. In 1A, the coordinate of the focus is a comma 0, but in 1B, the coordinate of the focus is 0 comma a. So in this case, the directrix is 0 comma negative a, or simply put, y equals negative a. Now, still on the equation of the parabola, number 2, 2a to be precise, if the vertex of the parabola is at the point x1, y1, then the equation of the parabola becomes y minus y1 all squared equals to 4a bracket x minus x1. That is the equation of the parabola, provided the vertex is no more at the origin. Okay, this equation is said to be in the standard or canonical form. So we will come across these terms later on, standard or canonical form. Note, focus and directrix, both of them on the vertex. If the vertex is x1, y1, then the focus will be a plus x1, y1, and the directrix will be x1 minus a, y1. Now, the second part of that equation, that is 2b, the canonical form of the equation of the parabola can also be, open bracket, x minus x1 all squared equals to 4a, open bracket, y minus y1. In this case, the vertex is x1, y1, vertex remains the same. The focus will be x1, a plus y1, x1, a plus y1. So you will notice that the focus also has changed if you compare this one with equation in 2b. Then apart from that, the directrix will also change. Directrix will now be x1, y1 minus a. Take note of these changes. Now, example 1. Find the equation of the parabola whose vertex is at the origin and whose focus is the point 5, 0. Solution. The first thing, let us recall what has been given in the question. The vertex is at the origin and the coordinate of the origin is 0, 0, while the coordinate of the focus is 5, 0. Now, since the vertex is at the origin, it means we are going to use equation 1a. Why? Because the vertex is at the origin. So since the focus has been given as 5, 0, and we know that that 5 represents a, so it shows that a equals 5. We then substitute in our equation. The equation is y squared is equal to 4ax. You sub 5 for a. So we have y squared equals to 4 into bracket 5x, and the final answer will be y squared equals to 20x. Example 2. Find the focus and directrix of the parabola y squared equals to 16x. Let's see the solution. From the equation given, y squared equals to 16x, the first thing, you compare this with the equation of a parabola, which is y squared equals to 4ax. We can't use the equation in 1b because the original equation given to us is y squared equals to 16x. So we have to use the one that is having y squared equals to 4ax. So when you compare your right hand side, our 4a will be equivalent to 16. Dividing both sides by 4, so that shows that our a equals 4. Therefore, the focus is 4, 0. And then the directrix will give us negative 4, 0 when you write it in coordinate form, or simply put, x equals minus 4. Example 3. Write down the equation of the parabola y squared minus 4x minus 12x plus 40 equals to 0 in its canonical form, and hence find Roman figure 1, the vertex, Roman figure 2, the focus, Roman figure 3, the directrix of the parabola. This one is 3-in-1 question. Okay, let's see the solution. Y squared minus 4x minus 12x plus 40 equals to 0. That is the equation given to us. The first thing is to express it in its canonical form. And to do that, we have y squared minus 4y equals to 12x minus 40. That is, the terms containing y will be at the left hand side, while other terms will be at the right hand side. Now, when you consider the left hand side, you have to complete the square. We are going to apply the method of completing the square. We all know that to complete the square, you will multiply the coefficient of y by half, by 1/2. That is 1/2 times negative 4, and that will give us negative 2. So we add minus 2 to both sides. The square of minus 2 rather. You add the square of minus 2 to both sides. So when you add it, we have y squared minus 4y. I said add, so plus, open bracket, negative 2 square equals to 12x minus 40 plus negative 2 square. So the next thing, you will then factorize the left hand side. When you factorize, we have open bracket y minus 2 all squared equals to 12x minus 36. Now we factorize the right hand side. That gives y minus 2 squared, y minus 2 everything squared equals to 12 into bracket x minus 3. Then when we compare this with the equation in 2b, that will give us, in 2a rather, the equation in 2a, that will give y1 equals to x1 equals 3, 4a equals 12. Since 4a equals 12, divide both sides by 4. That shows our a is 3. So if that is the case, from this extract, the vertex is x1, y1. So when we substitute, we have 3, 2. Roman figure 2. The focus is a plus x1, y1, and that will give us 3 plus 3, 2. When you simplify, it gives 6, 2. Roman figure 3. For the directrix, the formula is x1 minus a, y1. Substituting, we have 3 minus 3, 2. And when you simplify that, it gives us 0, 2. So if it gives 0, 2, you want to write it in a simpler form. It shows that the directrix is x equals to 0. Now, example 4. Find the vertex, focus, and directrix of the parabola x squared plus 4x plus 4y plus 16 equals to 0. The solution: the equation given to us, x squared plus 4x plus 4y plus 16 equals to 0, expressed in its canonical form, that will give us x squared plus 4x, other ones we move to the right hand side, equals to minus 4y minus 16. As usual, for the left hand side, we have to complete a square. We apply completing the square method. That is, you multiply the coefficient of x by half, that is half times plus 4. That will give us plus 2. So you add the square of that plus 2 to both sides. So we have x squared plus 4x plus open bracket plus 2 all squared equals to minus 4y minus 16 plus open bracket plus 2 close bracket square. You then factorize the left hand side. That gives x plus 2 all squared equals to minus 4y minus 16 plus 4. So simplifying for that, we have x plus 2 all squared equals to minus 4y minus 12. So when you factorize the left hand side, the right hand side, factorize the right hand side. So we have x plus 2 all squared equals to minus 4 is common, negative 4 into bracket y plus 3 close bracket. When you compare this with the equation of a parabola, here now you notice that we are using equation 2b. Equation 2b. Take note of that. So when you compare with equation 2b, we have x1 equals negative 2, y1 equals minus 3, 4a equals minus 4. So when you simplify that, divide both sides by 4, that shows our a is negative 1. Therefore, the vertex is x1, y1, which will give us negative 2, negative 3. The focus is x1, a plus y1, which will give us negative 2, minus 1 plus negative 3. And simplifying, that will give us minus 2, minus 4. The directrix is x1, y1 minus a. Substituting, we have a negative 2, minus 3 minus negative 1. When you simplify further, we have a minus 2, minus 2. Or simply put, y equals to negative 2. Now your assignment. Write the equations of the following parabola or parabolae in their canonical forms and hence determine their vertices. Foci. Foci is the plural of focus, and directrices. That's the plural of directrix. Equation 1. Y squared plus 4y plus 4x plus 16 equals to 0. And equation 2, x squared minus 6x minus 4y plus 13 equals to 0. So that way, we wrap up our lesson today. Take care and stay safe. Don't forget, submit your assignment to your respective further maths teacher. Thank you. Goodbye.